Welcome back, everybody. So, hey, what do you guys think of when you think of salt, right? I don't know about you guys, but I think of like table salt, right? Chloride, NaCl, right? That's what I think of when I think of salt, right? But the classical definition of a salt is actually a little bit more general than that. From a chemical perspective, a salt is essentially an ionic compound, an ionic compound That is to say, it's made up of ions that are being held together sort of loosely by their attraction to one another, right? Positive to negative, and so on. Containing positive ions positive ions other than the hydrogen cation, right? And negative ions other than a hydroxide anion, right? That is all it is. That is all it is, really, right? So NaCl certainly fits that description, right? If we stop and think about it. I mean, if you were to split this up, this is Na, which is a positive anion, or sorry, cation that's not hydrogen, check, right? And chloride, the chloride anion is a negative anion that's not hydroxide, check. Therefore, this is a salt, but it is certainly not the only salt. It's just a salt that's particularly tasty to humans, right? But it is not, by any stretch of the imagination, the only type of salt from a chemistry perspective that we see in the world. We're going to be talking a little bit today about the various methods for preparing salts, right? So essentially, ways salts can be formed. Can be formed. And there are about 5 major ways in which we see salts getting formed. The first and the most popular is one that we have actually seen before. At this point, you're probably actually getting tired of hearing about it. At least that's my hope, right? And that is the neutralization reaction. An acid plus a base gives me what now, class? That's right, a salt and water. And again, this is what's called a neutralization reaction because in a typical combination of a strong acid and a strong base, this gives you a pH neutral compound. It neutralizes both the acid and the base. So an example of this would be, for instance, if we were to take some magnesium hydroxide, right? And that's a base, by the way, in an aqueous solution, and we were to combine that with sulfuric acid, which is, of course, an acid in an aqueous solution, and we were to combine the two, what we would end up with is magnesium sulfate, which is a salt, and, plus water. Right? So notice that essentially what ended up happening here, and you would get, by the way, let me make sure my equation is balanced. This would be 2, the magnesium sulfate would be solid or aqueous. But solid, aqueous probably actually now that I think about it. And let me just change that up. Aqueous. And the O2, of course, would be a liquid. The H2O, would be a liquid. Okay, so that gives you your salt. And of course, your water, right? So this is by far the most common way that salt gets formed, but there are several other methods that we see occurring from time to time. So we want to make sure we discuss those as well. Okay, so just going to throw another at you. Another reaction that we tend to see is when we put an active metal together with an acid. Remember, we said that active metals and acids can react together, and generally what happens there is that hydrogen ends up getting liberated, right? So you end up with a salt in addition to your hydrogen gas, right? So an example of that, by the way, this is a single replacement reaction. Single replacement reaction. Okay. And an example of that, just, sort of playing off my previous example, if I took not magnesium hydroxide, but just straight magnesium, which in its solid state is a very active metal, right? And I added to that very same sulfuric acid that we have in the previous example. So there's my metal, and there's my acid. And I combined them, what would happen, right, is that this hydrogen over here would pretty much pop off from the acid, right? And then it would leave the magnesium and the sulfate once again behind to combine and become a salt. And in this case, once again, this would probably be aqueous solution. This would probably be a gas. The acid would have originally been aqueous, and the metal would, of course, originally have been solid. Okay, so that's the second example of this that we typically see. Okay, so here comes another. Very often, it will be the case that we will get just straight up a direct combination of elements. A direct combination. Direct combination of elements. So for instance, if we were to take some iron, let's say, and I were to add to that some sulfur, and I were to, I don't know, like heat those up together in a crucible or something, what I would get is iron 3 sulfide, which is, guess what? A salt. So sometimes what will happen, again, is that you'll simply get two elements straight up combining with one another to give you a salt compound. That is certainly not unheard of. Okay. So, another thing that we see from time to time is we will see two soluble salts, a soluble salt in an aqueous solution, and another soluble salt in an aqueous solution. Oops. combining, right? Essentially, this ends up being another double replacement reaction. A double replacement reaction that ends up leaving you with one salt that's still soluble and one insoluble salt that's going to essentially drop out of the solution as a precipitate. And again, just to give you an example of what that might look like, of how that might show up. For instance, if I had some silver nitrate in an aqueous solution, and I slapped that together with some salt, like just straight up sodium chloride salt in an aqueous solution. Both of those, of course, are soluble, right? What might happen in my double replacement reaction, right, is that these two would sort of pop off and switch places, right? So the sodium would pop off of the sodium chloride and go over here to live with the nitrate, like that. And then the silver chloride would combine. Now, silver chloride, as it turns out, is not terribly soluble, right? So probably when that happens, the silver chloride is going to precipitate out of the solution and become solid, versus this guy over here is probably still going to be aqueous, right? Okay, so there's one more sort of typical example that we might see of the way that a salt might be formed. So when we take a metallic oxide, like a metallic oxide, and we combine that with a non-metallic oxide, that will give us the salt. Just for your reference, as an example, if I took some magnesium oxide in its solid metallic state, right, and I took some SiO2, also in its solid state, so again an oxide but not a metallic one, silicon in this case, what I would get is a combination, all three of these getting smacked together to form a solid salt compound. Beautiful. And those are the 5 ways in which we might get a salt formed. And again, a salt is simply any ionic compound containing a positive ion that's not hydrogen and a negative ion that is not hydroxide. So any ionic component that does not have either of these two features associated with it. Fantastic. Thanks for sticking around, and I'll see you in the next video.